In this video, we are going to see an amazing algorithm which is of decision tree. So what is decision tree? How the decision tree is going to work internally? What the mathematical formula behind it? Guys, we'll go and entirely see from the scratch. Let's get on the computer screen and let's get started. By the way, first I'll tell you the basic intuition of decision tree. Okay, let's quickly select my pen and write something called decision tree. So what is the mean by decision tree? See, you know if else, right? So I'll write if age is lesser than or equals to 18, what I'll write here, then print me, you can drive. Okay, sorry, you can't drive. Lesser than 18, you can't drive, not equals to. If it is lesser than 18, you can't drive. Elif, guys, you need to know these concepts. Okay, elif my age is greater than 60, print you can't drive. You are a senior citizen, assume you can't drive. Okay, else drive. What I am doing, else print you can drive. What you can do, you can drive it out. Means you are not lesser than 18, you are not greater than 60, then you are from 19 to 59, you can drive it out. Now how to build a decision tree using this? See, something called first I'll in the root node I'll have age is less than 18. Okay, now if s, what will happen? If no, what will happen? Okay, age is lesser than 18, s, what will happen? It will print you can't drive. It will print you can't drive it out. If it is false, what it will check? If it is age is greater than 60, if the age is greater than 60, again it will divide into two things, yes and no. This is yes, I think this is no, right? Yes, this is yes, this is no. Okay, if it is yes, what is that? If it is no, what is this? Okay, now let's go and see the thing. Now for this also we have yes and no. Yes and no. If it is yes, he also can't drive. He also can't drive it out because he is a senior citizen. If no, he can drive it out. If no, he can drive it out. So you can see the tree here. A tree construction means, guys, again I am telling you, these things are called as nodes. Okay, these are called as nodes. Okay, these are called as edges. Okay, now this is called as root node. What is this called as? Root node, and this is called as leaf node. Okay, this is called as leaf node. Now you need to see here, so this is called as like depth. Okay, now here this is called as a tree depth. Okay, these are the sub nodes of this node. These are the sub nodes. For this we called it as a depth of a tree also. We'll call it out. Okay, now you saw, okay, by using a basic if else we can construct this. Now the point is, so what is decision tree and how the decision tree is work? Okay, so let's take an example. Here we have something called outlook, sunny, overcast and rain. Okay, three categories we have. We have how many categories? We have three categories. If it is sunny, he can play. If it is sunny, don't play. If it is sunny, don't play. If it is overcast, play. If it is rain, play. If it is rain, don't play. So this kind of things are there. So let's quickly go ahead and construct this decision tree based on it. Okay, let's go here, and what I'll do, first I'll select outlook. Okay, I'll select something called outlook. How many categories I have? You need to tell, guys, how many categories I have? Three categories I have. What is one? One is of sunny, one is of rain, the other one is of overcast. These three things I have. Now let's quickly go ahead and see. Where is my image here? Now 1, 2, 3, 4, 5. 5 don't play are there. Means entirely how many don't play are there? 5 don't play are there. Means 5 no's are there. How many s are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 9 s are there and 5 no's are there. Okay, sir, understood. Now here totally we have this. Now for outlook, what we'll have? Sunny. For sunny, how many for sunny, how many s and how many no's are there? Let's quickly go and see. For sunny, 1, 2, okay, 1, 2 no are there. Again 3 no's are there for Sunny. Okay, for Sunny, how many no's are there? 3 no's are there. Okay, for Sunny, how many no's are there? 3 no's are there. Now, how many yes are there for Sunny? Okay, you need to see that. For Sunny, how many yes are there? Okay, where is it? Here you have 1 yes, 2 yes. Okay, how many yes are there? 2 yes you have. 2 yes. Similarly, how many yes and no's are there for rain and for overcast? You need to check it out. Okay, let's quickly go and check it out. For what we did for Sunny and for rain we have. For rain, we have 1, 2, 2s and 3s, 1 no. 3s and 1 no we have. How many? 3s and 1 no we have. For overcast, how many we have? For overcast, 1, 2s, 3s, 4s. So you can clearly see here 4 yes and 0 no's are there. Now you can take an intuition from this. Okay, means the main thing is the outlook. How many are there? 9s, 5 no's are there. How many s or no's you have seen here? For Sunny, if it is Sunny, the probability is he is telling 2 times s. 2 times means the probability is 2 by 3. See here, what is the probability here? Entirely, how many are there? 2 plus 3, 5. Okay, 2 by 5 is the probability here. Now, probability of playing here, how much is there? How much is there, guys? You need to tell. Something called 3 plus 5 by again 3 here. Now, what is there here? 4. 4s means I can take and analyze. If it is overcast anytime, if the weather is overcast, if the outlook is overcast, I can go and play. So further split is no need. For further split, there is no need of further split, because if any 0 no's or 0 s occurs, you can typically say, okay, if there are 0 no's and 0 s anytime if you occurs, so you can literally you need to say, okay, this has no further split. What you need to say? This has no further split. Why? See, if I do further split also for overcast, if I do any time, I can play it out, right? Every time I have s. For that purpose, I am not doing splitting. Again, I am doing splitting here. How to do? Again, what field I have? Temperature, humidity, wind. Based on this, I can clearly split it out. Now, the main question arises. What? Splitting. How to split? What the main question arises? Splitting. How to split? Now, in the split, we have something called pure split. Pure split. And another called impure split. Impure split. Now what is pure split? Means this is the pure split. No further splitting is there. For that we call it as a pure split. Okay. Now what is impure split? Impure split means, see here. Here we have further subdivisions, further subnodes, subtree is there. For that purpose we call it as impure split. Now again the two main question arises. So what is the first question? Sir, how to select the root feature? How to select the root feature? How to select the features? Okay, how to select the features? For this we have something called information gain. Okay, we have something called information gain. Okay, information gain. And in the purity we have something called, in the splitting we have something called entropy and Guinea impurity. Sir, what is mean by entropy, Guinea impurity, information gain? Guys, let's go and see one by one. First, let me teach you what is impurity. Okay, what is entropy. Let's go and see what is entropy. So what is the entropy formula? If you ask me, H of S equals to, the entropy is denoted by H of S equals to, I have something called minus T, okay, minus P plus, okay, minus P plus log 2 P plus minus P minus log P minus. Sir, what is this P minus P plus, guys? Simple. What is P plus? Yes. What is P minus? No. True, false. Understood, right? So this is known as probability of yes, probability of no. That's it. Nothing. Okay. Now if I want to calculate this, now minus, what is my probability of plus? entirely. See how many like s are there, 9 s are there. 9 plus 5 how much? 14. So so I can calculate something called 14 by 9 by 14 log 2 9 by 14 minus how many no's are there? 5 are there. 5 by 14 log of 5 by 14. If I calculate this, what I'll get? If I calculate this, I'll typically get like some kind of answers and all. Understood, right? Some kind of things. Now if I go and calculate for this, then what I'll get? For sure I'll get 0. Means h of s equals to, what is the probability of minus probability of plus, means entirely 4 are there. How many are there? 4 by 4 log 2 4 by 4 and minus what is there? 0 by 4 log 2 0 by 4. Sir, what is 0? Guys, this thing. How many no's are there? 0 no's are there. So what is probability of no? 0 by 4. So for this purpose, what we'll get here? Entirely 0 we will get here. If you calculate this, you will get for sure 0. So what is 0 means? This is an pure split. This is an pure split. If you get beyond 0, something called 1 and all, what this mean? Impure split. Impure split. Understood, right? What is entropy and how entropy is calculated? How this is calculated? By seeing, I can get to know it has 4 s and 0 no's. What does it mean? It is an pure split. How the algorithm knows? By using entropy. And we have something called Gini impurity. I'll come back to it after telling you what is information gain. Okay, let's quickly go here and I'll write something called information gain. So this is my information gain formula. Now what is this? What is this? S means samples, F means feature. So category, which category I am going to do? What is H of S, guys? Again, what is H of S? Entropy. What is H of S? Entropy. Now what is H of SV? This is an subcategory entropy. Okay, this is a subcategory entropy. See here the amount of information gain here, you will, if you calculate this part, you will get some value. Okay, you will get, assume you will get 0.54 for first feature. For feature 1 you will get 0.54. For second feature you will get, how much you will get? Something called 1.28. Now which will be selected as a like root feature? This will be selected as a root feature. Why? The information gain in this feature is high. Understood, right? The information gain in this feature is high. So that purpose we are using the root node, or else the, see here, this category is happening based on the information gain only, right? This is happening based on the information gain. How the information gain is calculated? By using this formula. Now I told something called Gini impurity. What does this mean? I'll show you. And entropy and Gini impurity both are similar. Okay. Now Gini impurity. What is the formula of Gini impurity? Gini index formula equals to 1 minus summation of probability whole square. What is probability? Probability of S and no. Okay. Now if I do 1 minus summation of probability of S, assume I have 5S and 3 no's. 5 plus 3, 8. What is the probability of S here? Probability of S would be 5 by 8 and plus what I am doing? Summation I need to do 3 by 8. Okay, if I do this probability, I'll get some answer. Okay, I'll get some answer here. So this is also taken as the like purity and impurity. If this value becomes 0, then it is a pure split, else it is a impure split. Now you might have doubt, sir, when to use entropy, when to use Gini index? Guys, I will tell you. If you have small data set, then straight away go and use entropy. If you have large data set, if you have something large data set, then straight away go and use Gini index. Sir, why? Because see, in entropy you have some logarithm calculations. Okay, logarithm calculations. If your data is having thousands of categories, at that time what you will do? The calculation becomes the training time becomes very high, the computation times become very high. For that purpose, see here, Gini index doesn't have any kind of thing, basic math. Basic math is there, that's it, nothing is there. Okay, what is there? Basic math is there here. So better to use Gini index in the large data set and entropy in the small data sets. Guys, this is all about decision tree, and we have something called post pruning and pre pruning. Let's quickly go ahead and see what is pruning, how to check our model is overfitting. Okay, now for reducing the overfitting, these things will come. Analyze the score between test and the train. If it differs too much, it's overfitting. Yes, obviously it's overfitting. Pre-pruning, we will give max depth while creating the model's object. What does it mean? I'll show you. See, you have 100 categories. Okay, this is my 1, 2. Again, this would be have more things. Okay, now I need to decide how much depth I need to go. Shall I go till here, or else shall I go till here? How much depth I need to go? I need to decide it. When I need to decide it? Before model training itself, I need to do it. Okay, before model training itself, I need to decide. Okay, I can give max depth would be 3. So it will go till 3. 1, 2, 3. It will go till here. 3 things. If I don't give this, it will go entirely. What if you have thousands of categories at the time? What you will do? So you need to have a max depth. Okay, always remember to give the max depth. Else what will happen? It will memorize us the data and it will lead to overfitting. What it does? It will lead to overfitting. This concept max depth, we are giving it before the model training. This part is known as pre-pruning. This part is known as pre-pruning. Okay, this part is known as pre-pruning. What is post-pruning? We will change the max depth value repeatedly. Means after model training, what we'll do? We'll give the range. Okay, from 1 to 20, give the range. Okay, we are checking continuously which gives us a best accuracy. So this is called as a post-pruning, and pre-pruning is a hypoparameter. What is pre-pruning? It's an hypoparameter. Guys, this is all about the decision tree, and decision tree in classification. So decision tree in regression, how this will work. Okay, now you need to understand how this will work. It doesn't work on what? Impurity. It doesn't work on information gain. Here it works on something called mean squared error or mean absolute error. Okay, how it's going to work? Let's quickly show you the demo. Like, see here, there are these categories. Now this will calculate the mean square error. This will calculate the mean square error or mean absolute error based on what you will give. By default, it calculates mean square error. Now it will calculate the mean square error and it will store as a mean squared error itself. Further classification happen using mean squared error or mean absolute error. So this how in the regression the classification is happen, where we are not using information gain or else entropy, because here we can't predict, we can't use probability because these are the continuous value. This is for regression. For the continuous value we can't use this. Guys, if you understood this decision tree, guys, I want to congratulate you. It's a very, very important and the interview favorite concept. Guys, if you're not understood, go back and watch it out. That's it for today. I'll see you the next time.